Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about distributed systems. We will first know that what is a distributed system, and then we will discuss that how the distributed system works in advantage to a centralized system, and also we will discuss about the potential features of the distributed system, along with at last the disadvantages associated with distributed system. As we know that the centralized system is generally considered of only one system that can consider the most of the database and the connections that it can avail on this database among at least the processor that we can attach with the centralized computers. But is in the client server system architecture or is in a distributed system, that means there will be one network, and to each network there will be several systems that are connected to each other. So that is the key concept behind a distributed system of computing. So the client server architecture is one example of distributed system, but that is different from the typical distributed system in such a way that the distributed system doesn't have the server concept. Here, many sites can be connected with each other via the network, but there is no single site that acts as a server to other clients. So now we will stick to the concept of distributed one rather than having it in a client-server architecture. But we can imply the features of the client-server architecture in the distributed system and vice versa. Now, as we are talking about a distributed database that the systems are sharing with each other, to share this database among to the different sites that is connected to the network, we need a high-speed private network. What do you mean by a private network? That means what we are talking about a distributed system that must belong to a single enterprise or a unit. Here, it is not considered that for a single server there will be a different type of client. Say for the university example, we can have a distributed university example database where the university can have different distributed system on different branches, or a bank which have different branches to it. So in this type of scenario, the similarity type of the nodes or the sites that we are having must share a private and high-speed network. The way it is private because it belongs to a particular enterprise to which the distributed system is built on. Now, after we have thought about the network, the next one that we will talk about is the particular nodes or sites. So to say that there are multiple nodes inside the site and there are multiple sites that is connected to a distributed system. That means for an instance that for a city that the university is belonging. So say suppose the state university is belonging to many of the cities. And now in each city there are two campuses of that particular university. So what we are having? We are having two nodes to a site. There were three nodes in another site, one node at another site, and these three sites are connected with each other. As we can see that site A, site B and site C is connected to this network, one that we can have the network and the distributed system on these sites. So the sites and nodes are generally interconnected. The node can belong to a site and site can belong to a distributed system. So in this way, the distributed system works on having a private network and nodes that connect to a similar type of data. Now the next one is having a connection or the transaction. Now as the local connection and double connection are there, so in between inside there can be a transaction from one node to another, or it can happen that one node itself has connected to each other and then fetched a database query from it. Then it is known as a local transaction. So the local transaction stays by in a node or even the further in a site. Now when it is connected in a virtual network with other nodes in other site, then we talked about that as a global transaction. That means say when transaction A has been initiated by and so on this site and this particular node A, and it is being performed at a site B on a particular node C, so we can say that this type of transaction is known as a global transaction. So the main difference between these two is one is initiated and performed at the same location, another is initiated at one location and performed at any other location that is connected via a virtual network. So that is the global transaction and local transaction. That is one feature of this distributed system. So if we talk about that, what are the reasons that we built a distributed system concept? So there are three parts to it. One is the sharing of data, second is the autonomy, and third is the availability. First, we are talking about the sharing of data. As we are talking in a distributed system, as the name suggests, that we are sharing the data, we are distributing the data over the nodes. So now for a single database that can be accessed by many of the sites or nodes that is connected to the particular database. Now again, take consider of this university example, where if any branches that belongs to a city that can connect to the same university, where another city site nodes where it belongs to another city, it can connect to that university database too. So in this way, the sharing of data becomes extremely easy in a distributed system. Now only the database needs an own copy, that is an fetch copy or fuzzy copy of that particular site to have as in a global copy, and when it is shared via the network to the sites or the nodes, then they become their local copy. So in this way, the sharing of data is possible in a distributed system. Next is the autonomy. The sharing of data concepts arise with another concept that goes with an autonomy. That means how to control the share of data. Say suppose that a database is shared over the distributed system, and one university data, that means say for the computer science application, the computer department of that university has 5 seats among all the branches of that university. Now what happens, same two universities are want to update the location on which the computer science branch is happening. Now if there is one entry from one university end on the branch or other end for the other university end, and both at the same time where the location were 4, then any one of it can enter this university computer science department. Now what happens if there is no autonomy that we can provide to this university level or the distributed system, then there will be a problem. So we can provide two types of autonomy to this distributed system. One is a local autonomy, another is a global autonomy. Say for the information that must be stored within the site or the nodes of a particular site, we consider that as a local information, and any autonomy to handle this portion is known as a local autonomy. Say for the branch details like the classroom, room number, section number, that can belong to a particular branch, that will belong to a particular node in the system, has to be locked by a local autonomical system. But when the university is containing some general information like the computer science department of this university, like the example I have told you, that if there is any 5 seats available on the computer science department, so now it will be maintained by a global autonomy. So the global autonomy suggests for that the main part or the network will now connect to the database to see that whether to give the permission to one network or one site at on, and otherwise we can give 2 or more networks at once that particular permission. So now this will be done by the global autonomy. So what happens by this global and local autonomy is the locking of data. When someone wants to read the data as per the database management system, if there isn't 2 locks available, we will lock the data in a shared mode. That is, may happen that many nodes of different sites wants to read the data of a university brochure. So you can do that by acquiring a shared mode lock on that data. Now one university has read this brochure and find a discrepancy there. Then he or she should acquire an exclusive mode lock onto that university brochure, or save the portion of the brochure on which he wants to update the data. Now in this way, if two universities find the same problem at the same time, then only one of them is allowed to acquire an exclusive lock at that point of time, so that it can provide the most safest way to connect to this database from these sites. Now what we can see that the shared database is belonging to the network, or say most preferably it can be a cloud network based, where the cloud is storing the database which is being shared by the sites or the nodes. So it is being handled by the global autonomy, but for the local autonomy it is much easier. Now we can start with any other storage and then can have only the storage on the lock. That means the site will lock, and inside that site may have many nodes. So the many nodes can lock the shared mode on the local data. Otherwise, an exclusive mode lock if we want to update the data. So in this way, global and local autonomy can go to handle a distributed system properly. Now what happens within availability? Another advantage, which is the most important one for using a distributed system, goes within availability. That means as there is no central server to it, there is only a network on which every computer is connected to each other via the network. Now if any of the computer fails to connect, then there are other computers which can connect to the network and continue the operation very smoothly. So this is the computation availability that a distributed system can provide us. That means there will be the concept of the front end and the back end, but not with the server and the client architecture. Every site can have the front end facilities as well as the back end facilities accommodated with each other. That means even if a single computer fails to provide the autonomy to one system, then other computers can continue their operation without being any delay. What the user will see that a minute delay on the transactions, because one transaction need to be stopped that was happening on the failed site, and that need to be given to another site to be performed. Say one university transaction is not happening for their branch one, so they can request the other university branches to update that university on that hand. Now what is happening that using a distributed system, all the universities can have access to all the universities availability. So what they need to know that the existence of other systems, the concurrency of these databases, and also they need to know about that what transactions they are having on the other sides. Without these three information, distributed system cannot work properly. Say for an instance, if one university branch doesn't have the information of other university branch that is being newly added up to the university site. So what happens that if there is any update from that particular university, then all other universities will be not aware of that, and that will make an inconsistent data as a result. That is not desirable. So these three things we need to keep in mind while building a distributed system. Now, if the distributed system we are not using, the availability becomes a crucial one. Even if despite of the problem that we can face for the recovery from failure from a centralized one, which is much easier one than the distributed system, we choose to have the distributed system because in the business scenario or the real-time scenario, we cannot afford to lose such opportunities when we can having in a distributed system. Say for the airline reservation system, well, there are many competitors available. So if there is no distributed system, then it will be difficult for the airline managers to maintain their popularity among the users, because if it is using a centralized one and if one site is not working, then they can choose the other one for a distributed system. Now let us take an example and exemplify the distributed system on the local and global transaction and the autonomy to it. For example, say a bank have 4 branches to each other. Now one of these branches, the head branch, which keep track of all the branches of that particular bank. Now, if any branch wants to update their information, they first need to update on a branch information table or the branch information database, where we have not only the database of that branch but also all the branches information that is allocated to it. Now, in that way, we are contributing to a distributed system where we can have these 4 branches at the sites, among which we can have the nodes, because there is many possible that one city is having many branches. And now that is connected to this network of the branch information, which is being the shared database here. Now, say for a valuable branch, there is one account on which a user is having to deposit $50 to its account A117. Now, it can having this valuable branch and then have only the branch information as a local transaction, because the user, say user A, wants to deposit an amount to its money or account $A77. So what is happening here, that the user is informing and updating the money on the branch side of Halliwell. So it is not informing the other branches that they are depositing the money. And the Halliwell branch also doesn't need it necessary to keep informed about this updation on the account balance of user A, which is the sole information of its branch. Now, what happens that if a bank have 2 branches on, say, Hillside and Halliwell branch, and the user A from the Halliwell branch of account number A117 wants to deposit $50, or they transfer an amount of $50 to an user B, which branches is on Hillside branch of account number A30. Now it needs a global transaction, because first 50 will be deducted from the local transaction from this user A's account, and then the data will be traversed through the network. That $50 is now traversing through the network to go into some site where as a local transaction of updation and addition of $50 to user B's account. So in this one, we are having 2 local transactions and 1 global transaction that is associated to us. That one is maintaining the local autonomy. That means whenever the user A's updation is being made to $50, now it is traversing along the network. So an exclusive mode lock will be placed in the user A's account until and unless we have not been admitted or credited that account to user B's. After that, the release will be locked on an exclusive mode lock on both the user A and user B's account. Now, when we are talking about such distributed system, it is also possible that one branch of the bank is having a different distributed management system and another one is having the other one. So we can deal with different distributed system, but the schema should be unified for all the system that is belonging to a particular enterprise. And there can be a multiple database also that is attached to this shared network on a distributed system. Say for an instance, there are local databases for each of the branch, and there is one global database. One is having the information about the branches. So we are having a multi-database software where we can have more than one database, not only the relation, but also the database that is more than number 1 to this distributed system. The next one is the implementation issues that we face in the distributed system. Now, the first issue that we face is the atomicity issue. When we are having a global transaction, then the atomicity on the transactions become a crucial issue to maintain, because the local transaction doesn't have any problem with this atomicity, because the transaction can be performed at its wants because the local data that is concerned with this transaction. But when there is a global transaction, like the transaction I have told you as an example, that $50 will be transformed from user A's account, which is its one branch, to another branch's user B's account. So what happens here? Say suppose that the transaction is committed by the user A's after he is having deducted or debited $50 from its account. Now, while the shared data or the traveling of $50 is on the network, there is some problem in the network, or server B is having some problem. So the data that is being credited, the amount of $50 to user B, has not been completed. but the transaction from the user A side has been committed, which now results in an inconsistent state because the two processor doesn't have any communication to each other because of the commit protocol absency. So we now take to the 2PC or the two-phase commit protocol rules. So what is this two-phase commit protocol rules? That if there is one transaction that is a global transaction to a distributed system, so we must inherit any of these two. The first one is that even if the transaction is being part of that local transaction, it cannot commit itself until and unless the transaction is being completed to the user side. That means the transaction is initiated from one side and now the transaction will traverse through the network and goes to the other branches or the other sites too. If both the transaction hasn't entered the partially committed state, then it cannot go beyond this transaction. That means it cannot proceed further. Now, if it belongs to the partially committed state and one transaction has committed as in transaction end, that means it signifies that this transaction has ended. Now, if the other transaction has also ended, then only we can produce by the concurrency control manager or the resource identifier that the transaction will be committed. Say for an instance that one transaction has been in from user A side, but there is one failure from user B side. So the scheduler will now decide that to commit the transaction from A or B or both. Now either we can do that we are aborting the transaction from user A side. So what will happen when user B will recover? So it is up to the scheduler the partially committed result that we have from user A or just abort the transaction when it recovers from the failure. So it is up to the scheduler to provide this two-phase commit protocol that only commit will be done when two of the phases that are two ends of the transaction has been settled down or the transaction at its completion. Now the next one is a concurrency control problem. Because of the same problem that we have described, that $50 is being deducted from user A and till now it is not showing an update on credited to user B. So we are having two different sites that we are accessing the same transaction at two different sites. That means two processors are accessing the same data at the same time, and when we are having the exclusive mode lock onto this same data item. So we have the problem of concurrency now. So the concurrency control problem leads us with an inconsistent and non-durable data where we can provide the concurrency control with the locking mechanism that is supported by this global or local autonomy. So either the concurrency control manager needs to take care of either the local transaction or both the global and local transaction and provides the autonomy to provide two types of lock and two-phase commit protocol to ensure the concurrency and the atomicity of the problem. Now the standard transaction models inside a distributed system which requires that different and types of multiple operations that are collected as a transaction can be performed locally or globally by the sites on a distributed system. Now we need a meaningful way to do that. So we can either use the message passing system, which will be extremely expensive for this one because now we are having different types of data that is collected as part of a transaction. So now the transaction can either do the first one, skip to the third one, but that will not be a part of an orderly transaction or a serial transaction. So now what we can do, we can either stick to this persistent messaging system. In persistent messaging system, it just divides the transaction into groups so that it can be sent across the network and reach the network in order to the server or the other sites. And the second issue that is solved by this database distributed system is that whenever we are having the global transaction to which the sites is belonging, we can have that the transactions are now separated between the workflows, the column flows, the data flows, and all we can be managed by the workflow manager where we can see that from which side the data is moving to which one and finally it arises to which one, or even if the sites are simultaneously accessing a data or not. So if they are accessing the data simultaneously, then we can say that the workflow manager is working properly. Now, despite of this distributed system advantage, some systems chooses the centralized architecture rather than the distributed architecture. But why they choose so? Because when the designer designs this architecture, they need to take care of both the pros and cons of the centralized and distributed one. Till now, we have discussed that what are the distributed systems advantages so that we can choose it among the silver side of this centralized architecture. Now, what happens? There are also some cons by which some systems stick to the centralized one, becoming a simpler one. So we will now discuss about the disadvantages. The first one is the more bugs that is hard to detect. As it is a distributed system, and it can also happen that the site they are using to connect to a network are of different operating system and are prone to different types of bugs. So when different types of bugs are there belonging to the same database and fetching the same transaction, then it is very hard to detect then for which of the bug it is happening and how to detect and recover from the bugs. Another cost is the expenses, that the software development cost that to build the distributed system and all the operating system or all the distributed management system under a single software development is very expensive, and that is why some systems stick to the centralized architecture. And the last one is increased overhead of processing. As we know, either for the persistent one or a normal message processing system, the message passing is an expensive one, and we need to pass messages as we have different databases stored in different part of the sites belonging to the same distributed system. So now to pass the messages from one transaction to another transaction in a global way, there will be an expense and extra overhead on this processing. So these are the disadvantages that we have as for the distributed system. So distributed system is an essential where we are applying to the client server architecture or when we want to connect many sites at the same time. So thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.